Now, here's our same system of equations. We can write this as a matrix equation in this form. Okay, so knowing how to multiply a row by a column, it should be clear how this works in a manner completely analogous to what we did in the preceding class. Just to make sure, let's do an example. Multiply, without looking at the answer, multiply 5, 9, negative 3 row by XYZ column. What do you get? You should pause and do that without looking. But when you do, you remember that the scheme was first number in the row multiplied by first number in the column. So that'd be 5 times x. There's our 5x. Added to second number times second number, which would be 9 times y. Added to third number times third number, which is negative 3 times z. So adding, of course, negative 3z, we get negative 3z, or we get a minus 3z, and we can write it this way. Okay. Now, so we see our matrix equation. If we multiply the first row by x, y, z, we get 2x plus 3y minus 4z, and right there it is. And that's got to equal the first row of this column. And then if we multiply second row times x, y, z, you can do that. You should do that and see that that would be equal to the negative 3, and that's your second equation. And so third row times this gives you set equal to the third number over here, gives you the third equation. Make very sure that you see that, because you have to understand that this completely represents this system. Now, we also have the augmented matrix, and when I ask people to do this, everybody seems to have gotten it. The augmented matrix is just what you see here. We put the numbers from this matrix, just the coefficients of x, y, and z in the same format, and we put a dotted line here, and then we put the 1, negative 3, 1 here. And this very clearly represents this system in a very obvious way. The first row represents the first equation. Second row represents a second equation, and so forth. So that if we were to, say, add the first row and the third, we would get, what, 5, 1, 0, negative 2. That would correspond perfectly to the 5x plus y equals negative 2 equation that we all got when we eliminated z from the first two rows of this equation. So that adding two rows or adding multiples of two rows somehow together is going to give us a set of valid equations. You need to understand that. You need to understand that each row represents an equation, and if we do to the two rows what we would do to the two equations, we're going to get something valid. Now, our goal is going to be to reduce the augmented matrix to this form, where we have 1, 0, 0 in the first row, 0, 1, 0 in the second row, 0, 0, 1 in the third row, and these asterisks represent numbers that we have yet to determine. Having determined what numbers go here, just by reducing the matrix on the to the left of the dotted line to this form is going to give us a solution to our system. Because what does this mean? This 1, 0, 0 equal an asterisk means x, 1x plus no y plus no z, so we just have x equals whatever this asterisk turns out to be. And this row means no x, no z, but y equals whatever this asterisk turns out to be. And the third row represents z equals another number for this third asterisk. Now, these asterisks are just there to indicate that they're going to be numbers. They aren't equal to each other. They aren't equal to any specific thing. They just come out of the operations that we use when we reduce the 3 by 3 matrix here to the left of the dotted line to what we call the identity matrix here, with ones on the diagonal and zeros everywhere else. Again, because that gives us an equation. that gives us our solution. X is going to equal something, Y is going to equal something, Z is going to equal something. Make sure you understand that. Go back and replay this, whatever it takes. Make sure you understand how this represents this and how this will represent a solution to this. So, in a minute we'll proceed with that solution in the next clip.